Okay, this is Anthony Precella with his favorite college algebra class. Today we're going to be graphing ellipses and hyperbolas. We're continuing the discussion of graphing curves that we started the last time when we graphed circles. And we talked about finding the center and radius of a circle. There was that little phrase I'd say, okay, to find the center, change the sign of the number in the parentheses with x, then change the sign of the number in the parentheses with y. And with a circle, you have that radius. Take the square root of the last number to get the radius. But an ellipse, most people have an idea of what an ellipse looks like. It's sort of a flattened circle. It might look like this. Or it might be long, like this. Something like that. Now, every ellipse has what's called a major axis and a minor axis. The major axis is the long line segment that runs straight through it, cutting it in half. The minor axis is the short line segment. So we have a major axis and a minor axis. The minor axis, I'm not saying it's vertical. I'm saying it's the one that's the short one. Like on this one here, the major axis is vertical, it looks like. Vertical. Oops. Major and minor. Now, the equation of an ellipse will look sort of like the equation of a circle, okay? Looks like this. Oh, and every ellipse has a center, okay? So I'm going to use the point HK for the center, just like I did for a circle. And the equation's going to look a little strange because we're going to have these fractions. It's going to be fraction plus fraction equals 1. And the top part of the fraction, the top parts, will look sort of like the equation of a circle. Okay, we have x minus h squared, then over, there's got to be some number there. And I'm going to write a squared just because that's how you normally see it written in a book. But the important thing is down here there should be some number. And most times in books you see those numbers called a and b. But just some number here, then plus y minus k squared all over some other number. I'll call it b squared, just to have something fill in the spaces there. So these a squared and b squared just representing some numbers. Okay. So the way we're going to graph these is, well, you look at the equation, find the center, and you find the center the same way we did with the circles. Change the sign of the number in the parentheses with x, change the sign of the number in the parentheses with y. But if it were centered at 0, 0, do y'all remember with circles? If they were centered at 0, 0, did we have any of these parentheses or did we just have x squared and y squared? Yeah, there's not going to be any parentheses if it's centered at 0, 0. It'll just be x squared over a squared plus y squared over b squared equals 1. Now with a circle, you plotted the center and then you just moved over whatever the radius was. And if you were doing it with paper, you'd spin and compass, you'd spin the compass around. If you're using the MyMathLab graphing tools, you would still just plot that center and then move over what the radius is. So what we're going to do after we find the center for an ellipse, you see, you're going to ultimately you find the center and then you're going to be moving left, right, and up, down. Unlike a circle, the left-right movement won't be the same as the up-down movement. You move left and right, the square root of the number under x. Move up and down, the square root of the number under y. Now, these are all, on my math lab, these are all multiple choice problems. And some of these graphs, if I printed them out, but they look so small. So when you're doing it in doing your homework online, if you have a hard time telling what the graphs look like, there's this little magnifying glass that's by it that you can click on and get it larger. Okay? But here's the first problem I'm going to do. It's like your homework problem number 1. Let's see. Let me write it down. X squared over 16 plus y squared over 9 equals 1. So this is problem number 1 in our homework. Well, we're going to start off by stating the center, and I'll just do that right here. The center, this is like that first one we did with circles the other day. There's no parentheses here. So we're going to think of this as x minus 0 and y minus 0. The center is just 0, 0. Okay. The next one we'll have some parentheses up on top. So we're going to plot the center, and then you move left and right the square root of the number under x. Square root of the number under x. So left and right 4. Up and down square root of the number under y. Square root of, my purple pen isn't working, so I will use up and down square root of the number under y, square root of 9 is 3. So to graph this, okay. You know what, maybe I better do the x-axis and y-axis in black, because I can't tell it there. So there's the y-axis. And there's the x-axis. Oh. You plot the center, well, that's 0, 0. Then move left and right the square root of the number under x. So I'm moving left and right 4. 1, 2, 3, 4. 1, 2, 3, 4. Up and down square root of the number under y, so up and down 3. 1, 2, 3. From the center. When I say up and down, I mean up and down from the center. 1, 2, 3. And I'll connect these dots. Let me try my other purple pen and see. On this one, is the major axis horizontal or vertical? I'm thinking it's horizontal, right? Oh heck, this looks more like a circle than most of my circles I draw. But okay. So there's nothing real sophisticated about graphing these, and there's no graphing tools. You're just going to be, once you graph, look at the A, B, C, D choices. Sometimes students say, well, once they know this, they can just blow up each graph on my math lab and look and see which one of these is centered at 0, 0, left and right 4, up and down 3 from the center. And that's certainly fine. I want to give some terminology that's going to pop up in some of these problems, maybe 2 of them, maybe the next one we do. The domain, that word D-O-M-A-I-N, refers to the x values. And range refers to the y values of a graph. So if someone asked us, or if we were asked for this graph, what are the x values? Okay, all the x values are between what two numbers? -4 and +4. All the x values on this graph are between -4 and +4. So the way we say all real numbers between -4 and +4, including -4. There's a point at -4 and there's a point at +4, is with that interval notation. Remember that little bracket means include the number. Having seen that, could y'all figure out the range? Let's see, what would the range be? All the y values on this graph are between what two numbers? -3 and 3. Now, if you have to type in interval notation, make sure you're putting the smaller number first, not 3, -3. If you wrote the intervals like that reversed when we were doing the cut point method, you probably got it wrong, okay? And I don't know how many of you actually print out your homework. This one, it didn't ask for the range. It's just graph it, and you see how small they are? But again, when you're actually looking at them on your computer, tablet, phone, whatever you're using, there's a little magnifying glass that works pretty nicely, just blowing it up a lot. Now, this one's tricky because the scales are changing. Like answer C and B, it's from -20 to 20. And A and D are -10 to 10. If I could blow this up a lot, we would count and we'd say, okay, here on A, each mark is 2, whereas here on B, each mark is 4, 4, 8, 12, 16, 20. And so it's sort of hard to tell just looking at it which one is from -4 to 4 and -3 to 3. It's not B. It's not C. Is it A or D? It is A on this one. So if I were logged in, I'd click A and get it right. But you got to pay attention to those numbers there. The way this one, each mark is 2. And again, it's so small. That's the downside to me using this rather than just the projector. Okay? But I wanted to do it with graph paper. That's why I'm doing it like this. I think y'all could do one now that doesn't have that's not centered at 0, 0. This one's going to be this is problem number 3. Let me write it down. Problem number 3 says, okay, x plus 4 squared all over 25. Then a plus y minus 5 squared all over 9 equals 1. Oh, this is problem number 3 that we're doing. Well, this one's not centered at 0, 0, and you should be able to spot that easily because there's no parentheses up on top, okay? Excuse me, because there are parentheses. Problem number 1 didn't have any parentheses, but problem 3 sure does. So let's write out the center. To find the center, change the sign of the number in the parentheses with x, and then change the sign of the number in the parentheses with y. So what's that center going to be? A -4, 5? Left 4 up 5 is the center. Now move left and right, the square root of the number under x. Square root of the number under x. So we'll be moving left and right 5 from the center. So you plot the center, move left and right 5. Then move up and down the square root of the number under y, up and down 3. Now, let me go ahead and sketch my graph paper. Let's sketch the x-axis and y-axis here. X-axis and y-axis. See if I can move this up a little. Okay, I'm going to plot the center, left 4, up 5. 1, 2. So left 4, up 5. Is that right out there, the center, left 4, up 5? Yeah. Now, from the center, I'm moving left and right 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see. Now back at the center, I'm moving up and down, what? Is it 3 units? Yeah, so 1, 2, 3. 1, 2, 3. Y'all caught up with me? And connect the dots. Something like that. Okay. And, oh, this problem is one that asks, okay, what's the domain and what's the range? I'll show it in a moment, but I'll show the problem the way I printed it out. But let's go ahead and figure out this domain and range right now. I'm going to go ahead and put my brackets. Okay. Ooh, I should have labeled more numbers maybe on this x-axis and y-axis. When I started here and I moved left 5, what number am I at right there? -9, okay. And what about over here? When I moved right 5, where am I? Is it +1? Okay, so the domain would be -9 to +1, including those numbers. And the range, by the way, this 5 here is just for that point there, the center, in case you're wondering, what the heck is that 5 there? Okay. And I guess it's true for this point too, right? 1 up 5, okay. Now, what about these two? Where am I at 2? So using graph paper, you can sort of tell, okay, all the y values are between 2 and 8. Okay. 2 to 8. So this is how your homework will look. I don't know how many of you print this stuff out on paper before you do it, but if you do, here's the problem. Okay, it's going to make you choose the graph. This one in particular, you can sort of look and, let me do this. Okay. It should be in the, it's sort of a horizontal one, right? Not a vertical one. And it's in the upper left quadrant. So it's either A or C, but which one of them do you think it is? It is A. A is the horizontal ellipse. C is more vertical. So on this one in particular, it's real easy to spot which one it is. because there's none that look similar to it, really. But again, and it's hard to tell these little numbers out, how big is each unit, but when it's on the screen on the computer, it looks bigger, and also you have the little magnifying glass you can click and it blows it up really nicely. Okay. But as for the rest of the problem, it then says, okay, what's the domain? And it's just multiple choice. And you only get two choices. You only have two choices, either -9, 1 or 2, 8. The domain is -9, 1. The range is 2, 8. And then this problem demonstrates the way people are going through, taking these. I'm sure if we went back 10 years or so, probably this whole problem was just plot the graph, choose A, B, C, D. But as years go by, the people keep adding questions on there. And one day someone decided, hey, let's ask the last question, what's the center? Isn't that sort of funny? As really, isn't that the first thing you've got to do? There's just no way you're going to do this, be able to graph this without first finding the center. So the center is -4, 5. And you have to type that in with parentheses, or it'll say wrong. Okay. So this is graphing an ellipse. An ellipse is sort of a flattened circle. Are there any questions? Now, there's also, in this assignment, some curves called hyperbolas. So we've graphed ellipses, and now we're going to graph what's called a hyperbola. And I'm pulling this up just because look at the equation for an ellipse. The equation for a hyperbola is going to look very similar, except the middle sign's going to be a minus. Okay? A hyperbola can take on two shapes. Hyperbolas look like U-shaped figures facing away from each other. So it's two pieces. It might look like this. Okay. It might be opening left and right. Again, it's two pieces, not just one piece. Or it might be opening up and down. The equation for a horizontal hyperbola looks just like this equation for an ellipse, except there's a minus there in the middle. Just like ellipses, hyperbola and circles, hyperbolas have centers, but the center is a point right there in between the two curves. Okay, right out in there. Okay, so here's what the equation looks like. We're going to call the center HK, just like we did with ellipses. It's x minus h squared over some number. I'll go ahead and write a squared, although I'm not really doing anything specifically with a equals and b equals. I'm just saying, okay, some number in the bottom that you'll be taking the square root of, minus y minus k squared over b squared equals 1. Now, the equation of a hyperbola opening up and down still has a minus in the middle, but all this y stuff is going to be written first. Instead of x minus y, it's going to be y minus x. I write y minus, I'm writing all of this, k squared over b squared minus x minus h squared over a squared equals 1. graph these hyperbolas, we're going to state the center, then the left, right, and the up, down. So let's find the, well, I'm writing the same thing I did for ellipses. We're going to be moving left and right the square root of the number under x, up and down the square root of the number under y. And these are just multiple choice problems. And I'm going to do problem number 8 first. So we're going to do problem number 8. And here in particular, the graphs show so small. If printed on paper, they look terrible, okay, like this. But when you see them blown up, they look better. Okay. So this is problem number 8. Let me write it down. We're graphing y plus 2 squared over 16 minus x minus 4 squared over 4 equals 1. Now, I didn't write out in words what I wrote out for circles. To find the center, change the sign of the number in the parentheses with x, then change the sign of the number in the parentheses with y. But I've said it today, and under document sharing, I do have a handout summarizing, just like with circles, everything I'm saying about ellipses, about ellipses and hyperbolas. But the first thing we're going to do is find the center. And this is extremely, extremely tricky. Okay? To find the center, change the sign of the number in the parentheses with x, then change the sign of the number in the parentheses with y. Now, I'm going to tell me what the center is going to be, or should I give you two choices? I'll give you two choices. Is the center going to be -2, 4, or 4, -2?
2, 4.
Okay, let me reword that again, or let me repeat it. To find the center, change the sign of the number in the parentheses with x, then change the sign of the number in the parentheses with y.
So it's 4, -2.
4, -2. Okay, make sure you're going x, y. Okay, I'm not saying change the sign of the first number or the number in the first parentheses. I'm trying to make sure you go x, y. Now for the left, right, and up, down movement, it's tricky. Look at what I've written. The left, right, square root of the number under x. So I'm going to be moving left and right the square root of how many?
4, 2.
Okay, the square root of 4, so 2 units left and right. This is the thing that makes hyperbolas tricky. Okay. Make sure you're going left and right. And then you'll move up and down the square root of the number under y. The square root of 16 is 4. Now, I should have already asked this, and I didn't. So, how is this hyperbola opening? Is it going to be looking like this one, or does it look more like this one? Is it opening left and right, or up and down?
Up, down.
Up and down. It depends on the first variable. Let's go ahead and make it. Let's write the sentence. Hyperbolas open in the direction of the first variable. If the first variable is x, you think of the x-axis as being left and right. It's opening horizontal. if the first variable is y, you think of the y-axis is up and down, and the hyperbola is opening up and down. So Becky Medley said that years ago, and I remember that. Hyperbola is open in the direction of the first variable. Now, to draw the rest of this, I'm going to draw my xy axis. Drawing the x-axis and the y-axis. And I'm going to start off by plotting the center. Right 4 down 2. Right 4 down 2. So right there is the center. Oh wow, that 4 doesn't even look like a 4. But now, we're going to move left and right 2, up and down 4 from the center. Just put those dots and then stop. Okay? Left and right 2, up and down 4 units from the center. 1, 2, 3, 4. 1, 2, 3, 4. Now, at this point, you can sort of figure out what the graph looks like just based on knowing how it's opening and those 4 points. When you have curves like this, the turning points are called a vertex, each turning point of a curve, and this, the plural form of vertex is vertices. Hyperbolas have 2 vertices. So this one's opening up and down. 2 of these 4 points that I plotted here are the vertices. If it's opening up and down, could y'all tell it's the up and down points that are going to be the vertices? If it had been opening left and right, it'd be these left and right points. So the graph looks sort of like this and this. Okay? But I did that in pencil because I'm not sure about the width. I'm not sure if this is going to be a real skinny graph or a real wide graph. If you want to get the exact width of the graph, which I don't think you need to get to choose which one the homework is, A, B, C, D, there's something you could draw called the fundamental rectangle, which looks like this. If you connect these 4 points with a rectangle, you drew a rectangle in here, and again, most students don't need to do this to figure out which. And then draw a big X. I'm going to draw a dotted X. I think in some of the homework, it depends on the web browser. Sometimes they show the X as solid. Sometimes they show it dotted. Sometimes they don't show it at all. But this X will help you get the width right. See, it's just the diagonal. It's passing through the center and the 2 corners. Passing through the center and the 2 corners. Ooh. Oh, you know what? I'm always making these things skinnier than they should. Why am I saying that? Well, these dotted X's, those are called slanted asymptotes. You don't need to know that name, but those for this course, okay? If you're taking trigonometry, you'll hear about asymptotes a lot. But for this course, and with the asymptote, the graph runs out beside it but never actually crosses or touches it. So this graph I drew skinnier than it should. The actual graph should look more like that. It's a wider graph. So drawing this big X helps me get the width right. But generally, if you just find the vertices, that's enough to figure out which one of the graphs it is. And let me see, I don't even know where I'll put that graph. No, that's not it. See, here, these look well, let me see. If I lift it up, can I do a physical zoom? They're trying to show the X and the U-shaped curves. Well, there's two of them. Well, which one's opening left and right? It's certainly not. D's opening left and right, isn't it? So just which one looks most like that? It's not D. Let's see. I'm thinking it's not A, right? A, the curves, and again, if I can pull this up online, you hit the magnifying glass and it blows it up really nicely. But for some reason, this thing prints out so small when you do the print. I'm thinking it's not A, it's not B. Is it C? Okay. And again, this looks terrible just because they're so small, but it is C. To make up for it being such a messy thing, they say, okay, we're not going to ask you for the domain and range. That would be a little bit messier, okay? So they only ask for the domain and range on ellipses. So, you know, maybe I better pull up some and do one online right now. Just pull one up so y'all can see how the graphs look. Okay, so I think I'll stop the video at this point, but let's summarize. Hyperbolas open up and down or left and right, depending on that first variable. Okay, and and then the rest, you find the center by change the sign of the number in the parentheses with X, change the sign of the number in the parentheses with Y. Make sure you're going X, Y. This problem number 8 here is a very, very tricky problem because some of the multiple choice answers will have -2, 4, that wrong center as one of the graphs. Okay, so make sure you're going X, Y. Also, when you're doing left and right, make sure you're going square root of the number under X, not square root of the number under Y. Okay? So let's go ahead and stop this now, and we'll continue just up on the board. But for those of you watching, thanks.